Marquam Hill to North Macadam, which is a very interesting and exciting opportunity for PSU and OHSU to come together in more ways than one. And so I'm currently speaking into this microphone, so those people joining us remotely will hopefully be able to hear me. And so just a word about asking questions later. If you touch this microphone in front of you, then you can be heard by all people. And so what I first thought we'd do, since this is the beginning of a new term, we'd just quickly go around the room and introduce yourselves, and then we'll get going.
I'm Jennifer Dill. I'm a professor in the School of Urban Studies and Planning, and I help co-organize this with Rob.
Mauricio Leclerc, I'm MERP, second year.
David Hamston, basically a second year to fifth year MERP student.
Chris Monsieur with the Oregon Department of Transportation.
Merle Hill with the Oregon Department of Transportation.
Paul Bender, MERP and PhD student.
Allison Wildman, second year MERP.
Shana MERP. Kelly Sullivan, second year MERP.
Okay, thanks. My name is Matt Brown. As Rob mentioned, I'm project manager with the City of Portland's Office of Transportation. I'm not an engineer by background. I'm a landscape architect. Been a project manager with the city for about 8 years, and worked on a lot of fun and interesting things over that time. I think this is probably sort of tops them all in terms of sort of unique or interesting projects. I guess I should say I'm a bit of a generalist. I'm not a specialist or an expert in any particular field. I sort of led the team that put this project together. So I'll do my best as you get into some of the detailed questions maybe later to answer those. But we really had a team of probably about 10 folks in total working on this. And it ranged from transportation planners and sort of policy analysts on that end to a consulting team that included traffic engineers and a tram and gondola engineer. There really aren't that many of those around, but we've managed to find a couple, and there's a gentleman down in Nevada who helped us with this. He does a lot of tram and gondola work around the country in North America. So with that, what I thought I'd do is I just try to give you a little bit of an idea for some of the things that we looked at, some of the context that the aerial tram grew out of. And I always think it's important in some of these, and a lot of you may have read quite a bit in the press about the tram, and obviously there were not always a lot of sort of warm feelings about this project in the community. So, I think it's always important for us also to step back at the end of the day and sort of ask, what kind of things, in retrospect, do we think could have been done better, especially in working with the community on this one, because I think that's really been one of the sticking points on this project. So, let me walk you through a little bit of the project background. Really, this project obviously started with OHSU, and it started as they became interested around about 1998, and expansion into the North Macadam area. And it seemed to make a lot of sense because it was physically proximate. It's only a few thousand feet away from the Markham Hill campus, but of course, as you start to think about that, you have to think about how you connect those two areas. How are you going to get between Markham Hill and North Macadam? At that time, they commissioned a study that looked at a whole range of alternatives for connecting those, assuming that was going to be something other than say, just a surface transit option, which was still one of the options. But they looked at a whole range of things, including funicular rail, people mover. Funicular rail, I don't know, some of you may have seen in Pittsburgh, go up Mount Washington. It's essentially a rail that goes up an incline. So it's different than a rail, but it's, you know, sort of keeps the rail car level as it goes up this incline and sort of up and back. We have one in Pittsburgh. It's sort of the most common one that people talk about, but it's essentially a rail that goes up a fairly steep incline. So rather than a streetcar, you know, that's running, you know, parallel to grade, this is running essentially level, you know, going up an incline like so. People mover systems, which there's a lot of different examples of those. If you think about those, it's like if you're at an airport, Atlanta Airport, or some of these other ones, they're the things that look like subway cars, essentially. They look a lot like a subway. A lot of times they're cable-driven, a lot different than, again, just a rail. Streetcar was actually one of the options. It included, in the early stages, thinking about linking the streetcar not down to North Macadam, as we're currently thinking, but actually up to Markham Hill, to OSHU, instead of back down that way. And then the tram was one of the projects that was looked at, and their recommendation coming out of that was that the aerial tram was the connection that provided the best reliability and served their needs the best in terms of linking those two areas. Growing out of that, then, they also were beginning to think about how they wanted to develop on Markham Hill and how OHSU and the other institutions up there would develop on this very difficult piece of property up there. It's not the place that you would today start a medical institution of the type that we see up there, but that's where they are. So really, this was a legislative process that was initiated with the city's Bureau of Planning to consider land use changes on the Markham Hill. And that process is also intended to sort of bring some resolution to this tram issue, which by now, I guess it's about a year and a half ago. By that time, you know, sort of the camps had been set. People, you know, in the community had really caught wind of the project and begun to sort of voice their opposition. And the whole idea was, let's have this kind of public process that's going to resolve not only how Markham Hill should develop, but also can tackle this question of the tram. And ultimately, that plan then was adopted by City Council this July. Now, one of the things that plan did not necessarily contemplate were a lot of the alternatives for connecting. So it sort of tackled the question, but it didn't do it in a lot of specifics. And it became clear to a lot of us in the city that really needed to be done. And as the plan was nearing completion, there was really people getting stuck on, well, what is this thing? You know, what is this trend? There's this policy language that's being put into the Markham Hill plan, but we still have no idea what this looks like, how it's going to work, or what the alternatives really are. And we essentially respond to that at PDOT by saying, look, you know, we can resolve this fairly quickly and give you an idea for what the alternatives are and what their impacts are. And, you know, if you're going to go ahead and make a decision, let's make it an informed decision. And that essentially led to about a 2-month process where we put together a report that looked at various alternatives. I don't have copies for everyone, but I do have some copies here of our alternatives report, and I'll be going through some of the information that's in here later.
What does SCTS stand for?
Oh, good question. I think I have that on the next slide, but it's Suspended Cable Transportation System. And this was, again, sort of in this Markham Hill plan, this was the response to the tram, was to actually, it got more vague as time went on. Instead of being the aerial tram, became the suspended cable transportation system, because these other ideas started coming out. Well, what if it's a gondola? What if it takes some different kind of thing? And so instead of the plan defining it more closely, it seemed to become more vague even as we came along, which is another reason that we felt it was important to sort of jump in here, I think, and lend some more information to the process and begin to define that a little bit more. And what it came out to, and this diagram sort of points out that you had, on the piece of work that we were doing, which resulted in this report, you had this sort of evaluation design issues. We were looking really at a project level of what is this connection? How should it be made? What are the design issues? Technically, how does that work? And on the other side, you had the Markham Hill Plan, which is really, a different process, talking about the policies and regulations that would govern development both on Markham Hill as well as in the areas around that and the impacts of the development on Markham Hill. So these processes were sort of running concurrently with the idea that they would both come together at that city council hearing in July, and that council could have, essentially our report as part of their decision-making on the Markham Hill Plan.
Was the alternative study that you guys did just looking at different alternatives, assuming suspended cable, or was it looking at
It looked at, I'll get to that in a second, but it did include, it included a shuttle bus system, and that's what the neighborhood wanted us to look at. So, just to give you a quick idea for the process, we put together a 5-stage process that included first step, the process development, second step, the alternatives analysis, which again was that 2-month process we went through. And then following on from that, some additional steps, including, if needed, evaluating any of the policy or regulatory conditions around that, looking at then the further design development of that. What is it, once we've decided on how we're going to connect, what does that look like and how does it fit within the context of the community, and then finally on to PE, or preliminary engineering, final engineering, and construction. So this was really a process that was intended to get at the city engineer making a recommendation at these steps all along the way to city council. We worked with Planning Commission in the early stages of this process, and the process included really some advice that we got from the community, and Planning Commission responded to that advice. So the process was essentially something we took to city council that they approved. What I'm going to walk you through today is primarily that second step of the process, which was looking at the various ways you could connect Markham Hill to North Macadam. The ultimate then action coming out of that was this went to City Council, and they have the ability to either approve or reject or modify our recommendation in any kind of way. So that included a public hearing and a few public open houses along the way. A few assumptions that we built into the study, which I think are pretty key. First of all, it's a little bit telling, too, about the process that we had to highlight these assumptions, because I don't know that there had been a lot of community buy-in to these, but we had to make some assumptions heading into this. First, that an OHSU presence in North Macadam is desired and appropriate. I don't necessarily think that the community had fully embraced that idea yet when we had started in on this process. Second, that their stated travel time needs of 10 to 15 minutes, total trip. That's not just in vehicle, but it's walking out of my office, walking into the next office on the other campus. That 10 to 15 minutes is acceptable. And anything beyond that is pretty much non-acceptable. Another assumption is that all these systems would operate basically 18 hours a day, 7 days a week, and that the costs that we used, for comparative purposes, we had, again, pick a baseline. And we chose to use TriMet costs as that baseline, assuming that, again, this is like a public transit facility being operated with public transit unions and those kinds of costs that come along with it. So it was a very important thing. In the end, it was all relative. It wasn't absolute. We were trying to just compare across these alternatives what the costs were, but that was an important assumption. It was one that was challenged pretty heartily as we went along. Just for some context, what North Macadam really began to emerge then as playing a role in what became defined as a science and technology quarter in the South Portland area. It includes the area that we sit in now in the University District and PSU. It includes Markham Hill, OHSU and VA and Shriners facilities up on top of the hill. And the whole idea was that in order to take advantage of the developable property that's down in North Macadam and maybe even begin to fill in some of the property between North Macadam and the University District, you need to have good connections. And those connections are served in two primary ways. And the green line represents this idea of a tram linking Markham Hill to North Macadam, or some kind of system. Doesn't necessarily have to be a tram. The orange line being the Central City streetcar extension down into North Macadam and linking the Central City and PSU down into that area. The whole idea really that you're going to create this kind of nexus of research and potential to spin off economic development down in North Macadam based on biotech, based on the research that's happening here at PSU. Really trying to create some synergy in that area, but still linking it quickly, reliably back to the core campuses of PSU and OHSU. I'll run you through the 6 options now that we had, that we discussed. The first option was a shuttle bus option. And just to orient you, the OHSU campus here on the left, Terwilliger Parkway is running along through here, Sam Jackson Park Road up in here. There were 4 different routes that we analyzed. Here's I-5. You can see right through here. 4 different routes analyzed in this area. Did travel times on each one of these, and what we basically found was that the average travel time in off-peak hours was around 10 minutes in the vehicle and about 20 minutes total trip, just under 20 minutes. But it was susceptible to traffic. So during peak hours, obviously that time went up. Again, on average, 14 minutes in the vehicle, about 23 minutes total trip. So you can go back to those assumptions, 10 to 15 minutes. You know, this wasn't working really as a reliable thing. I actually did my own. They weren't included here. I did my own little test times one night. I had one trip from Markham Hill down to North Macadam. It took me 40 minutes because there was some congestion associated with, there was like something on the Ross Island Bridge, and that kind of that unreliability is really a problem when you come to that. Yes.
So if any of the shuttle bus options included things like striping lanes for bus only or building a new bridge across I-5, issues like that to streamline the travel time?
It did. There were some capacity improvements that were considered. I mean, we couldn't run those, obviously, because they didn't exist. But there are some improvements that are considered along there. For instance, the 6th and Carruthers, adding another lane down in there that we thought would be important. But the basic bottleneck is the Ross Island Bridge, ramps, and everything associated with that. So in order to get around that, you would have to do something like an overcrossing. And that wasn't considered, no. We then compared a lot of the costs. I'm not going to really get into these too much. There were some initial capital costs with buying the buses and the operating costs. I think one of the things that we did was we tried to anticipate a 30-year life cycle cost. We thought that was very important in terms of doing a cost comparison where you're taking both the capital and operating costs for these systems into consideration. And that became really one of the basis for cost comparison throughout. So with a shuttle bus, you have not only the operating costs of having 6 or 7 drivers, again, on call for those 18 hours a day, 7 days a week, but you're also continuing to buy new vehicles over time. You have maintenance of those vehicles over time. So all those things were sort of factored into our life cycle costs. At this point, we start getting into the aerial alternatives, the remaining five options. Option 2, the Gibbs Street Tram, is the one that was originally proposed by OHSU. And this is what we call a bi-cable aerial tram. I'll get into that in a second. It runs along the Gibbs Street alignment. So just from here, just to the west of Barber Boulevard, all the way down into North Macadam, it's on an existing city right-of-way. It goes over then the Lair Hill neighborhood. Now this is a historic district, South Portland Historic District. A lot of you may have been down in here. A lot of older sort of single-family homes in this district. And you can just tell by the map that it's been chewed up for years by transportation improvements. It's really been divorced from, in all directions, from the rest of the city. So it's this real enclave down here. So the Gibbs Street Tram essentially flies straight over that alignment. There would be one tower to the east of I-5 and Macadam Avenue in North Macadam. It would be about 185 feet tall. Let me just briefly describe. We looked at 3 different aerial systems. I'll describe the bi-cable tram here. This is in Germany. The bi-cable tram, essentially, you think about it almost as a railway in the air. The 2 main cables that you see there are stationary cables, and they're strung at very high tension between the upper terminal and the lower terminal. So very high tension, and because of that, they can span very large distances, which is different than the gondola that I'll show you later. So these are stationary cables at high tension, and then there's a third cable that is actually hauling the tram back and forth. And you have two, and they're running, in reversible fashion back and forth past each other. So as one is going up, the other's going down, and then they reverse back the other way. So they're very simple systems, really. It's an example of a lower platform. They can hold, because of the tension and the high tension, the high loads they can carry, they can also carry, in some cases, 150 passengers. They can be very large cars. In this case, we're recommending essentially an 80-person car. We would expect to be loaded to about 60 at capacity, but it's designed for an 80-person capacity. And this is probably, structurally, is what would probably happen up at the OSHU campus, where instead of having a tower, the tram would essentially just integrate into the upper landing. So you wouldn't have a separate tower up top. The tower and the landing platform would essentially become one structure at the top. And this is at Stone Mountain, Georgia, just showing a different type of treatment. We looked at a number of different things in the neighborhood. At a low point, the tram gets about 67 feet off the ground. Now that's at an emergency stop. So typically it's flying about 15 feet higher than that over the neighborhood. But at an emergency stop, driven down to the ground, that's its low point. And what we tried to demonstrate basically were, the system will be visible from some, but not all of the blocks. And I think there's a number of different things to consider as we're looking at that. Is it visible from the interior of the block or from the house, or where is that visible from? And we looked at a lot of that in the report itself. The key here, where the tram becomes really reliable, is in its travel time. It's 2.8 minutes travel time from point to point. So it becomes a very fast, very reliable, and when you add that to the walking to and from, you get about a 12.5-minute total trip. Initial capital costs of just over $10 million, operating costs slightly higher than that of the shuttle bus system, and over the life cycle, then capitalizing that, you get about $2.6 million cost per year. This is where we got into some of the other options, though. We also looked at something that included connections into the neighborhood. One of the problems with the Gibbs Street tram is that it flies right over the neighborhood. And one of their arguments against it has always been, what's in it for us? This thing's it's going by our street, but we can't get on it. There's nothing is here that's of benefit to us. It's a valid argument. So one of the options that we looked at considered a second tram down to Barber Boulevard. And that did a couple things. One, it provided access into the neighborhood that folks could walk to and use. Second is that Barber Boulevard is a very important transit corridor in southwest Portland. And the ability to essentially feed Markham Hill with the transit resources that are along Barber Boulevard was pretty critical. To take not only, for instance, the number 12, or the 44 or 45, or all these other local lines that are running there, and allow people to transfer directly to the second tram at the bottom here to Markham Hill, rather than coming downtown, getting on the 8, making the trip back up to Markham Hill. But also gives you the ability to, instead of running all the express buses up and down the hill, up and down Markham Hill, through all the curvy roads, up into a very congested situation already, you can take them to another point and essentially provide a transfer at that point. Now the system here is slightly different. This is still considered a tram, but it's slightly different. Smaller cars. It's what we call a monocable tram. It's really even simpler than the bicable tram. You can group smaller carriers together. In this case, we probably recommend 2. But the difference here is that they're attached to the cable. So the cable is not only pulling them, but it's also supporting them. So you have this sort of continuous carrying around of the cable. The one thing, if you think about a chairlift, it's like a chairlift essentially at a ski area where the chair is attached to the cable. The one difference here is that, like the bi-cable tram, it would actually run back and forth. It would be reversible. So the cars wouldn't actually go around the bull wheel at the bottom. They would stop and go back up the other way. So again, you'd have these two sets of 2 cars each sort of running back and forth against each other.
Where does that take?
That is in St. Thomas, Virgin Islands. And this is the same one right here. One of the advantages, actually, for this system is that it can also, you can see it's a very tight footprint up here for where the system lands. So it doesn't require a lot of land to implement. And this is down at the bottom here again. So a very tight footprint, relatively speaking. When you look at that section, then you have an additional tower into Terwilliger Parkway. And that's something that needs to be considered. It's about 155 feet above Terwilliger, but this is a section sort of through Terwilliger Parkway looking at that. The alignment was chosen really to get that up and over Terwilliger without sort of clear-cutting the swath up through there like you'd see for a transmission line or something like that. So it would actually get up and over the parkway fairly quickly. The Gibb Street tram still remains, sort of as we had talked about before. This monocable tram would have about a 1.5-minute trip between Barber and the top. And when you include that into the total capital cost with the Gibb Street tram, you're adding about $5 million onto the cost. The annual operating costs go up to $2.8 million, but the life cycle costs go down. And I think that's really important. I need to sort of explain why that is. They go down from what we had shown before, primarily because if you redesign the regional transit system around that Barber stop, you're actually able to try and make calculated for us. They could save about $750,000 a year in servicing Markham Hill by reorienting their service to that stop. So instead of running all their, express service to Markham Hill, they could feed that lower stop, save a lot of time and operating expense in doing so. Yes?
In your capital cost, does that include some kind of a pedestrian bridge over Barber Boulevard to help the neighborhood residents reach that stop?
No. One of the things that it did include improvements to Barber, though, that would improve the crossing. The bridge, if you think about the cross section there, the neighborhood actually sits about 30 feet below Barber at that point, and then you come up to Barber and it's flat, and then it goes on up Terwilliger. So a bridge across, would leave you up in the air. Bridge below would leave you substantially down below on the other side. My experience in looking at pedestrian bridges everywhere in the country is that unless you're essentially at grade, people won't use them. They will cross at grade level regardless of what you build for them over the street, unless it's, let's say, an interstate. They will cross at street level. So what we did was we assumed a crossing signal, median refuge islands, other improvements there that would help people get back and forth. Really try to do that. Yes?
Did the express buses, the TriMet Vision replacing, make a single stop on Markham Hill, or did they make multiple stops on Markham Hill?
I believe they made a single stop on Markham Hill. It's hard. I'm trying to remember. I think they stopped there at the South Hospital, and that's the only place they stopped. But that's a good question. I'm not sure.
And that is a single stop with a shuttle service once you're up on there.
Right. And it's there at the South Hospital? Is that where they stop? Yeah. Okay. Thanks. Yes.
Those smaller cars, like they're pretty small, so they couldn't hold people and a bike, or it doesn't look like they would hold bikes very well.
They may not. You could probably get those to be about 12-person cars. You could probably squeeze a bike in there. The thing is, and that's one of the things when we looked at the gondola alternative as well, is that the cars are much smaller, and it provides a lot less flexibility in what you can carry on those cars. And when you're thinking about a medical institution, it's like, what might you carry between these areas? It becomes a factor to think about. Yeah. Okay, let me run on. A few more to go through here. This is where we started looking at a gondola option. And this is still keeping the Gibb Street alignment. And I'll describe the gondola in a second, but you'll notice that on the plan, again, we're trying to address this idea that you could integrate a midpoint stop along the gondola system into the neighborhood and begin to take advantage of the connections to Barber and providing some neighborhood access. Now, the tram, if you think about it, is, you got two cars going back and forth. It's possible that you can do a midpoint stop, but it literally has to be exact midpoint, or else you're leaving another car sort of hanging in the air while you stop the other. The gondola doesn't have that problem. I'll explain the mechanical system in a minute, but you can essentially provide interim stops along the way, and that's part of the flexibility and part of the appeal for using a gondola system. Unlike the tram, though, there would be probably a minimum of 7 towers along the alignment to support the system. And I'll explain why as we look at this. This is a gondola system. You see many more cars. They're constantly circulating on this rope. And this is in Barcelona. This is at Vale. And what you can see, if you look up at sort of what's happening up here, you see a whole variety of wheels and everything. You also notice that it's just suspended by the one cable and being hauled by the one cable. So, and then the car itself, I believe this is an 8-person car, so the cars themselves are much smaller than the tram. And what you have are these incredibly long distances. You need about 100 feet at each of the stations to slow down, get into the station, have the gondola ready to load and unload. And those wheels on the top sort of come through this system here. The car itself is released from the cable, and these wheels begin to carry it through the station, slow it down, and the car continues to move very slowly through the station as it's loaded and unloaded before then it's accelerated, reattached to the rope, and sort of sent on its way in the other direction. So the systems are much more complex mechanically than the tram systems. You also notice that, it would be impossible to have an attendant on each of these cars. You have so many cars on this system. The tram has one attendant per car, but the gondola cars are most likely unattended as you're going through this. And you have a bowl wheel. This is just another view of sort of the mechanical system that's required at these endpoints on the gondola. This would be something like what the upper terminal would look like up at OHSU if a gondola system were used. There's a lot of different ways that those systems have been designed and sort of detailed out. The other interesting thing about the gondolas, which we explored on another option, was that they are flexible in their alignment. The tram really has to be straight line. It cannot vary in its alignment. You're just stringing these with tension. But the gondola, because you are able to sort of remove the car from the rope and detach it and get it on and get onto another way, onto another rope even, through that system, you're able to do these turn points. This is in the Middle East. I'm not entirely sure of the exact location, but this is just an example. You can see where they've made a very tight turn with a system. So this would potentially allow us to get into other areas of the neighborhood that were perhaps there was a less of an impact. Yes?
With exponentially more cars and more people sort of getting on and off those vehicles, would you not also run the risk of stopping and starting that system much more because there are more people involved at various points along that system?
I think the reliability of the system is a lot less certain than that of the tram, and it's one of the reasons that we felt pretty uncomfortable recommending that as a system. It takes a heck of a lot of upkeep, and the chances for breakdown are much greater with the gondola system. It's just another example of a bottom terminal. So when you look at in the neighborhood itself, whereas with the other, in our cross section, you sort of saw these two little cars floating over the neighborhood along with some cables. The difference here with the gondola is that you also need to draw the tower in, and there's these towers at points along the alignment in the neighborhood itself. And they're going along a public street, so in some way you also have to make accommodations for how that street remains open, if it does remain open. This is just one idea where, we do what's called a portal tower, where it basically bridges the street itself before supporting the gondola up at the top. The midpoint stop at Barber then, this is where you would have to build a structure over Barber Boulevard itself in order to accommodate that mechanical system. And if you look from this point to this point, you need about 200 feet to house this mechanical system as it comes in, slows down, detaches, load, unload, speed it up, attach it back to the rope, and send it on its way. So, and then you have the loading and unloading platforms that need to be accommodated. I had the hardest time drawing this because there's like multiple levels involved and everything else. But the best, really the best way probably to describe this is in section where you're going to have get people up, meet ADA, and get them up to that level and loading and unloading on that structure. So at a minimum, you have to build some sort of overpass structure that will also house the mechanical equipment and loading and unloading platforms over Barber Boulevard. So it got to be a little expensive just to accommodate that. The average travel time on that was about 7 minutes, 14 and a half minutes total trip. So again, it's just sort of under the wire there on what the stated travel time needs were. A little bit more expensive on the initial capital cost, and about 50% more expensive on the operating costs, which again sort of gets into the complex mechanical system. Really is a big operating cost issue, and so when you have a life cycle cost, again, it's another 50% higher than some of the other options that we looked at. Two more real quick. We did look at a couple. These last two options looked at, well, how could we potentially avoid the heart of the neighborhood, essentially, and could we look at some other options for where these might be aligned? You'll notice, just before I add on anything else here, you see, here's the Ross Island Bridge coming across, all the ramps and everything associated with that. The city undertook a study a few years back to rethink about how all that worked, the South Portland Circulation Study, and basically begin to reattach a lot of the streets through this area and reduce the impact of these ramps. And basically what it does, takes the Ross Island traffic and brings it basically up Kelly to this point. So that'll be the major movement, removes all of these ramps in this area, downgrades NATO to more of a neighborhood main street, and then reattaches the neighborhood streets across here and essentially frees up this land for redevelopment in the middle. Concept, that's what works. The reality is it's $30 million away from being done. So it's one of the things that we want to look at was, well, gee, there's all this sort of dead space now. Wouldn't that be a logical place to put this overhead system where it's not, flying down a neighborhood street? And that's where we looked at, again, the two different types of technology. One is looking at the tram and getting it down where it would land to the north of the Ross Island Bridge in North Macadam. In this case, again, you'd have one tower just to the east of I-5. And the travel time still makes a lot of sense. The capital costs go up quite a bit because you're acquiring property along the way. It's not sort of spending its time neatly down the middle of an existing right-of-way, but you're now flying over property that probably needs to be acquired as you do that. The operating costs are pretty similar. The life cycle costs go up a little bit just because of the higher initial capital costs. This is the one that, the sixth option, sort of the last one that we looked at, was the one that I think had the most promise from an urban design standpoint, but also had some flaws. And that was to use sort of the flexibility of the gondola system to bend this around, sort of take advantage of the sort of the dead space in the middle of the neighborhood here to align the tram, or to align the gondola in that area before bringing it back down into North Macadam, either in this location or potentially you could go north of the Ross Island Bridge as well. It could turn either way. You also had the opportunity not just to have the stop at Barber in this case, but also potentially integrate another stop to the internal to the neighborhood. Again, that was something that a lot of folks in the neighborhood felt was worth looking at. Again, number of towers in the neighborhood associated with the gondola. The crossing over Barber is very similar to the other one. It just also happens to incorporate a turn. So the cross-section remains pretty much the same. The potential then for the stop in the internal to the neighborhood is those blocks that we would reconnect and open up for redevelopment. You also had the opportunity potentially to integrate the gondola system into the development in that neighborhood. And this is just a quick suggestion of, it could even be part of development in that area. Part of the downside, though, to continuing to speed up and slow down and reattach and detach and do all this with the gondola is that the trip begins to get longer and longer and longer. So in that case, you have about a 9-minute trip in the vehicle, 18.5-minute total trip. The capital costs for this are pretty expensive given all the structures and the higher cost of the gondola system itself. And when you look at the operating life cycle costs, this is really the most expensive of the options, given the even more complexity to the system that you're adding in. So in the end, really, I just want to touch on some of the evaluation factors that we looked at. These were things that we went through with the Planning Commission ahead of time, with the City Council as well. And they're broken down in a number of subcategories under each one of these, but I won't get into that. There's the neighborhood impacts, things like views to and from the system, noise, the kind of impact on parking, property values, things like that. We looked at a whole range of issues underneath the neighborhood impact category. Transportation access and efficiency looked at how well does this system integrate with the surrounding transportation system. So that's where things like looking at Barbara Boulevard became incredibly important in terms of our evaluation. Feasibility of the study. We showed some of these alternatives that landed, for instance, north of the Ross Island Bridge. Well, these are landing on essentially an active barge operation versus the ones that are landing south of the Ross Island Bridge were landing near a property that OHSU already had an option on and was ready to basically redevelop. So, in terms of the feasibility and development timing and all that, the ones north of the Ross Island Bridge aren't really very viable options for us, say, over the next 10 years or so. Costs, which we ran through, were obviously consideration. Maintenance and operations considerations are sort of part of that. In public safety, there's a lot of differences between these different systems in terms of the attendance on the cabins is one example. If these are public systems, how safe or secure is one system versus another, but also there are subtle differences in their operations in wind and what happens if there's a fire under the alignment and things like that. Those are all things that we considered.
Yeah. What about ridership estimates?
We looked at ridership estimates as well. Those had already actually been performed prior to us coming in. We'd gotten a jump on some of those. The ridership for the aerial systems were essentially thought to be equal, at least for the ones that landed down in the south of the Ross Island Bridge. We also had ridership estimates for the shuttle bus, which greatly decreased. And actually, let's come back to that in a second. I can do some more detail on that. So what we ended up recommending was Gibbs Street tram with a second tram down to Barber. And that was recommended for a number of different reasons. One was that we felt the gondola system, as a mechanical system itself, was untenable, and that it had also additional impacts in the neighborhood that we felt were fairly unacceptable. The number of towers, the structures over Barber, things like that seemed to have more of a negative impact. This also really met the travel time needs that were stated, the best of all the systems. The tram system, in and of itself, is a very reliable transportation system. And when you can look at being able to get to that platform knowing that a tram is going to show up no more than a minute and a half from now, and that I can be down at the bottom another 3 minutes later, is very important. And part of, you can question the wisdom of the cities putting these two buildings, at opposite ends here of 4th Avenue. But, as I travel from the Portland building, for instance, down to meetings at the 1900 building over here, I have to account for that travel time. Now, if I had to also account for that in terms of when's the bus going to show up, do I have to worry about travel congestion, all that kind of stuff, and I have to worry about, well, it's at 4:30, I may have to account for a half an hour, I may have to account for an hour, I'm not sure. It becomes very difficult for people to do that. Now, you're sort of asking researchers, professors, doctors at OHSU to account for that time in their schedule. And that's one of the reasons that we felt that accounting for travel time was very important.
This is probably considered, actually kind of a little bit of a sick question, but what about like the possibility of it being sort of a target for somebody to...
It came up. I mean, that's one of the things we wanted to look at. For the most part, you can't say that any structure is not susceptible to that. Certainly they would be. Our engineer felt that really the targets that you have here are the towers themselves and perhaps the stations. It's always a possibility.
So in other tram systems, and say in other areas around the United States, has there been any kind of history of anything?
There was one in Italy 4 or 5 years ago, an American combat plane hit.
Right.
Right. A gondola system.
Right. Right. That's right. That was one example. And that was one of those things where they claimed it was unmapped, and there's a lot of things that went on with that. There have been some incidents. The gondola is another system that hasn't. There was a fire on one of them recently, that caused problems. So there are some safety issues with that, but the feeling was that you could design around these. For instance, the tower that's to the east of Macadam that street is not going to be open to traffic, and just because the tower is taking up so much room, you can design other kinds of things into that would, say, not allow someone to drive a truck into it, or I just started thinking of worst case scenarios. Someone's got a truck full of fertilizer, they want to drive into it, and then you can prevent those things from happening through the design around that. But this does fly low enough, though, that it's really not in flight patterns, so that for the most part, I was assumed not to be an issue, a design issue here. So again, just in terms of the recommendations, we looked at travel time, access to transit. This is a tough one. Why I threw this up on the board in front of City Council, I said one of the reasons we're recommending this system is neighborhood livability. You can hear the scoffs behind me. And it's hard because it's hard to convey to someone. It's like, I'm not saying this is without impact. Clearly this has impacts on the neighborhood. But of the options that we're looking at, we feel this is the best one. And people will continue to take issue with the city on that stance. But when you look at, for instance, the shuttle buses running back and forth, it's not hard to imagine that the highly paid doctor who is trying to get between these two areas, when faced with a 50-minute shuttle bus ride, doesn't just start hopping into his own car and driving back and forth. And these shuttle buses are running by houses at ground level, in the neighborhood. So it's, we're trying to work on saying, look, we know this isn't without impacts, but overall we think this is still the best choice. Maintenance considerations, again, the tram is a very simple, very reliable piece of equipment. Long-term cost analysis, development impacts. I'll get to that in a second. Yes?
This is kind of an all-around question is, and I don't know if the Marquam Hill plan addresses this, but what exactly is the negative as to why an underground fuel loop was not considered, i.e. like, the West Hills Tram.
Mm-hmm.
It goes through a hill also. It would have the same environmental impacts and rough. I would say roughly around the same cost. Obviously, there's different factors in it. But why was that not considered? Primarily because of cost. We
We didn't include it as a specific alternative. I mean, in retrospect, would it have been hard to include alternative number 7, had an underground one? Probably wouldn't have been. But when we looked at the cost for implementing that, it had about $50 to $60 million in capital costs. The operating costs, some of the neighborhood folks come in and say, hey, look, the operating cost for this, it'll run itself. So the tram has, you can buy systems for the tram that are fully automated as well. I think the point is we probably wouldn't be comfortable with any kind of public transportation system being run in just an automated fashion. So, and just so happens that our engineer who worked on this for the tram, there are 2 manufacturers of trams in the world, Doppelmayr and Poma, and they also make people mover systems, which is what you'd put into this tunnel. So it was very easy for us to get a handle on the capital and operating cost side on that as well. We knew we were same ballpark. These are cable-driven systems underground. It's the same mechanical equipment, essentially, different application. So we felt that just the cost, it was so far out of the ballpark that it really wasn't worth pursuing much more. And that sort of leads to this development impact question as well, which is, it's a tough one for people to get their arms around, because a lot of people want to look at transit applications as being 100% about moving numbers of people between point A and point B. I think we've had pretty good experience in this town saying that you can use transit for more than that. It can and should be more than just a method for moving people from point A to point B. It should also be something that gets you what you want, sort of along its alignment, at its ends, whatever the case may be. In the case of North Macadam, what it gets us is, and we had a development economist do a quick analysis of this for us. What it gets you is an OHSU presence in North Macadam that you wouldn't otherwise get. It gets you a density of housing down here, and now we're considering code changes that will allow up to 200-foot towers, residential towers down here. It gets you a density of housing that you would not otherwise see. And it gets you basically a time frame for development that's moved up from what you would have otherwise seen. So the end result of having this kind of this permanent commitment to a transit link between Markham Hill and North Macadam is that you get things on the development side in North Macadam that you would not otherwise see. So previously we were looking at 5 years, if we're lucky, before we get our first spec office building down there. Maybe it's 100,000 square feet, and you get 5-story wood frame apartments. Instead, what we're looking at is that within the next 5 years, you have a 400,000 square foot OHSU building coming out of the ground, with a few more to follow closely on its hills. You have probably 800 housing units, some of which are in some fairly significant and tall structures down there, so you have a density that you wouldn't otherwise get. And a lot of it is because you've made this commitment to link Markham Hill down to North Macadam. And there's a market that you're linking, there's an energy that you're bringing down to the district that wouldn't otherwise exist. So there's other pieces to that. And again, they're sort of subtle, and they're not everyone necessarily agrees that that's the reason to do this. But there are things that we're looking at. So here's where we're going next. We're now moving into the design development phase. Again, you may have read a little bit about this design competition that's starting to take shape. And the intent is that after the first of the year, there will be a design competition involving probably 3 to 5 firms, pretty much international reputation, fairly young architecture and engineering firms. And the intent is to really get some creative thoughts about what the system can and should be, and to begin to think about how this is knitted into the community, into the surrounding neighborhood, because that's really one of the things that has not happened to date. How do you provide benefit to the surrounding neighborhood? So the design competition is a process. Looking at mitigation of the system is a process, and figuring out how to pay for it. That's all going to be coming up in the next piece. Said I'd go through some of the things that we learned, or maybe that we could go better, so we'll do that and wrap up. I think from the get-go, when I was describing sort of the background of this, you notice that it started with OHSU. And I think what's happened from the beginning on this is that from day one, there's been polarization on this. OHSU has stated what they want, the neighborhood stated what they they want or don't want, and there's been no middle ground. And this polarization takes form in many different ways. You have these citywide goals, economic development goals, versus the neighborhood goals, and which one takes priority. You have this new technology versus the neighborhood and historic preservation. And again, which one is going to take priority? You got, on one side, just as simple as yes versus no, and no one is sort of thinking about how you take advantage of the discussion to make it work for everyone. So that's sort of where we stepped in, that was the environment we stepped into, and frankly, it hasn't moved much off of that since we started. Part of it is, we had 2 months to complete our study. That does not give you time to sit down and mediate and listen and think about how you can come out of this with a win-win. Like I said, I think what it gave us was an opportunity was to make sure that our city council is making an informed decision. That's really what this amounted to. I also think it pointed out that there's a need to address this area of the city in a holistic way. You can see the results of not doing that have been, that neighborhood has felt the results of not doing that, essentially. They've been cut up by all these transportation improvements. There's been really no consideration for how it is linked or integrated into the rest of South Portland. And really that is the bottom line issue here. I think as we move forward, one of the things that we hope the design competition will begin to contemplate is how you begin to re-knit this neighborhood into the South Portland area, and how we can take advantage of this project. It's not mitigation. You're talking about essentially reestablishing, trying to improve that neighborhood, make things better than when you left them. If we were talking about mitigation, I'd be talking about putting power lines underground, and sort of calling it a day. I think we're talking about something more here, which is how do we leave this neighborhood better than we found it? How do we really try to create or recreate a great urban neighborhood down here? So we need to be able to deal with some of the problems that have been created over the last 50 years down here. So that's it. I'd be happy to answer any questions you have on this at this point. Yes.
Is there any possible competition between the tram gondola proposal and extending the streetcar in terms of funding? In other words, could City Council say, well, we'll do one or the other, but not both?
I think right now both projects are critical to North Macadam and to success. So I think if we want to see some of the things happen in North Macadam that we'd like to see happen, which includes getting OHSU down there, potentially PSU as well, having a presence down there. Both of those projects are going to need to happen. They're both going to have to happen fairly early. So, yes.
How much did TriMet propose saving annually by cutting their express buses?
It was about $750,000.
Were the ridership losses netted?
It wasn't ridership loss. It was simply efficiency. So.
Let me see if I understand. In other words, express buses that are delivering people to OHSU from various neighborhoods,
right,
are truncating at Barber,
right,
where they have to transfer to another vehicle.
They transfer to the tram,
and that's going to lengthen their travel time.
It would actually reduce it. If you think about this, folks coming from on the Barber Boulevard express bus come up around Sam Jackson up onto the campus. Takes quite a bit longer, rather than transferring at Barber and taking a minute and a half tram ride up to the upper terminus.
How frequently do those trams run?
Every 2.5 minutes. It's because they're back and forth, just that slight little alignment right there.
So how many people are offloading an express bus headed to HSU, and how many of them can be accommodated on a tram?
You could get probably about 20, 24 per trip. So there may be some times where, you're going to have to wait for the second car to come. But again, they're pretty frequent. What happens now is a lot of people, this is especially helpful for, a lot of their cost savings came in just think about the number 8 buses, which run from downtown up to Marquam Hill. I mean, sometimes you'll get 2 or 3 right in a row at periods of the day. A lot of those, people are coming in, the number 12, for instance, on Barber Boulevard. transferring number 8, going up the hill. Now I get off at Barber, transfer, go up the hill right from Barber. I've relieved enough stress that instead of having to have 3 number 8s in a row, now I only need 2 to accommodate the same level of service. I actually had someone in the community question me. It was like, well, are you talking about reducing the level of service to OHSU? No. The number 8 should still run on 5-minute headways, up there. That's the level of service we're talking about. But in order to meet the ridership demands, we think we can do it more efficiently in this other way. So, yeah, there's still number 8 every 5 minutes, but it's not like there's 3 number 8s every 5 minutes in order to accommodate the ridership. And that's where some of their cost savings come as well. So it's not just and it's not all their express service, but some of their express service would make sense to feed Barber. Others would probably still go to the hill. So it's not all of it. Yes?
Just 2 questions. The operating costs are being paid by Tram at the city, OHSU, riders?
Hasn't.
Covering the not
Right.
the riders'
Hasn't been clarified yet. The city hasn't, at this point, the city hasn't taken any responsibility for the cost of either implementing or operating this system. So.
And have you considered linking it, once you get it down to Macadam, picking up across the river, someplace in north?
It's come up. It has come up. Actually, the Planning Commission sort of struggled with that. They were having a hard time in their deliberations on this, and in part because they were saying, well, what does this mean for the rest of the city, developing these policies for the tram, Some of them could see the value of jumping the river. Others were afraid that this just opened the door to a tram everywhere in the city. So, it was a hard one for them to, and I can see, going across the river makes sense. And you got OMSI on the other side, you got PCC on the other side, there's other things to link to. But at this point, we thought that one controversy was enough before we start the next. Yes.
So I have an email question from an observer on the live stream, and the question is, what sort of pass would be needed to ride the tram? Could neighborhood people use it?
We fully concede that this is a public facility. Otherwise, I don't know that we'd be contemplating using the public right-of-way or really sort of being involved as we are right now. It's really unclear yet sort of how that is going to work out in terms of who pays for what, and is this part of the TriMet system, and if so, does your TriMet pass work on there, or is this something different? Obviously, if we think about this as a public transit system, we want it to be as efficient as possible and not have people buying 3 different tickets in 3 different places for 3 different types of way getting around town. So it needs to work, simply put, at that level, but it's not resolved yet. Yes?
Talk a little bit about OHSU's funding contribution towards the capital costs. I'd imagine that they're contributing in some way.
That hasn't been resolved at all. And right now, what I will say is that the city, through the Portland Development Commission, is in development agreement negotiations with developers down in North Macadam as well as OHSU. So I know those questions are being kicked around right now. Yes?
How were the residents of Lyerville involved in the process of selecting alternative, and what was their preferred alternative? I know they probably don't want the tram, but what was their preferred?
Well, you have, there's a group called No Tram to OHSU, which a lot of folks have probably heard of, composed of a lot of people that live along Gibbs Street as well as some other people in Lair Hill, and their preferred alternative was the shuttle bus, because it doesn't fly over their head. They sort of liked the underground alternative too, because they felt that didn't have the kind of, again, the visual impact that the other system had. It's sort of interesting though. I mean, again, I think we were into that polarization issue. They did their own shuttle bus runs. They came up at the same times essentially that we did, but they said, well, it's a off-peak, it's 9.5-minute shuttle bus ride from North Macadam to OHSU, therefore it's acceptable. And the second half of it, it's like, no, it's also walking out your office. It's your entire trip that needs to be the 10 to 15-minute window. And that never, again, I think they were just more intent on trying to stop the tram versus, really anything else there. And, I hope we can move beyond that. I think the City Council has sort of made it clear what their decision, their preference is. So, yes.
Do you know of any examples of this type of tram, the recommended one, used by any public transit system, U.S. or abroad?
The one example, who's seen Spider-Man? Because the one example is at the end, speaking of disasters. The Roosevelt Island tram links Manhattan over to Roosevelt Island. The reason I'm bringing Spider-Man is at the end of the Spider-Man movie, and the villain cut the rope and sent the thing plummeting. So luckily we don't have the Green Goblin to worry about or whatever. But that's the one application in the U.S. It's been pretty heavily used by the residents there. It was originally intended as a temporary connection between Manhattan and Roosevelt Island until the subway was built, and it sort of became so successful that they've just kept it there. But it's beginning to show its age a little bit. They have it's sort of redundant to the subway system, and they're sort of questioning whether they want to keep operating it just from a cost standpoint. So, yes?
From the city's point of view, like to develop the area, you probably would prefer having more stops than the seventh option or the sixth option you showed. It's probably more, good for you, for the city, than just one shot to an OSU versus OSU. And how much value you put on that connectivity versus providing a direct link?
That's a good question. One of the kind of assumptions going into this was, when you think about that science and technology corridor diagram that I showed, that said, look, as an economic development goal, the city would like to develop sort of a jobs platform based on growing the biotech, science, technology corridors, and we think we can do that in North Macadam. There's the land there. We have the research institutions at PSU and OHSU, sort of committed to working with that. And one of the Battelle Memorial Institute was hired to look at this question of synergy, to say, well, what happens, in order to grow, this kind of industry, what are the synergy needs here? How do researchers relate to each other, and what kind of environment, if we can envision this place down North Macadam, this place on Marquam Hill, what kind of connection needs might need to be made in order for that to be a successful research environment? And that's one of the things that sort of led to that travel time assumption, or the travel time need, was that there needs to be a lot of interaction between those researchers. There's Gordon Davis, who works for OHSU on this, puts in a good one. He describes the typical day of an OHSU researcher, which is, he's seen patients up at the hospital at Marquam Hill in the morning doing his rounds there. He has to teach a class then across campus at some of their other institutional buildings. He's got a research lab down in North Macadam that he needs to go down, meet with his research team on, back up for evening rounds, perhaps back down to research. There's a lot of movement around. And all along, there's also a need for interaction with his colleagues. So this idea that you need to have this very fast, very reliable connection, because there's literally trips back and forth by many of these researchers all day as they fulfill their three different roles, say, for the institution. So that became one of the driving kind of forces behind that. And when you look at these other connections, they're critical, they're useful, but to the extent that they sort of got in the way of what was seen as being the key to creating that synergy, they became to sort of fall down the list a little bit more. And in the end, that internal neighborhood connection, for instance, while I love it as an urban design idea. I think it's the right idea. But it's also, the benefit was fairly limited in terms of the number of people you're actually serving with that. So it becomes, you're trading out one benefit for another, and it sort of seemed that the main goal of this was to begin to grow that sector down in North Macadam. So, yes.
What are your ridership estimates for the two trams?
I don't know those right off the top of my head, but I'll read them out of here real quick. The tram ridership, we had both in 2007 and 2030 ridership projections. And in 2007, the ridership was estimated be between around 1,100 and 1,500 per day. And in 2030, between 3,800 and 5,500 per day. And that's pretty well below the capacity of the system actually itself. And gondola actually has a greater capacity than the tram. Sure. 2007, the ridership was about 1,100 to 1,500. And in 2030, it's 3,800 to 5,500.
And that's just for OHSU to North Macadam or both?
It's three major types of trip. Essentially, it's broken down in three categories. And what was broken down is what was called trips that must be made. So these are the inter-campus trips, sort of the one I was just describing to you, the researchers sort of shuttling back and forth. And that accounted for nearly half of the trips on the system. Then you have what we call the induced trips. These are your transit connections, visitors to the area, things like that. And that accounted for the bulk of the rest of them. And then you have a smaller piece, probably about a tenth of the trips, we call them discretionary trips. You may have a residence on Homestead, in Homestead, for instance, on the hill, taking the tram to get down, walk along the greenway, stuff like that. So in early years, those trips are a little lower than they were later when you have things like the greenway, when you have activity in North Macadam, actually it begins to attract trips like that. So those are the three categories, basically. So it's probably, 90% of those trips are in some way related to OHSU, either the research trips during the day or like the transit transfers of people going to work.
But so you are including then the people who were previously going directly on the express bus to OHSU and are now transferring at Barber.
That is just the Gibbs Street tram.
Okay, that's right.
Yeah. So the smaller tram, what we did is, and I can give you those numbers as well, just the tram between Barber and Marquam Hill, again, we looked at sort of 2007, 2030. We used the Metro model to sort of figure out what we thought the future connections were just by including a link in the model. So early on, monocable tram ridership projections. In 2007, you have about 500 to 700 trips between Barber and Marquam Hill. And then 2030, you have about 2,200, 2,800 trips between Barber and Marquam Hill. So those are essentially the transit trips that are either transfers from the local lines or taking some of the express service and routing it to that stop. Yes?
This seems to be a fairly inexpensive way to span difficult terrain. A system like this
for taking light rail into Vancouver across the Columbia River instead of a new bridge in the interim or permanently, or going across the Willamette River from downtown Portland in one or more different areas?
I think it is, but it also sort of depends on the application. I mean, one of the limitations of the tram is that because it only has two cars, its capacity by definition is limited. So, and especially the longer the span becomes, the lower your capacity will go. So even if you put on a 150-person car, if you increasing the span is going to increase your travel time. So it all depends on the application. How many riders you're trying to serve, and sort of almost at a per trip level as well. It's like what's the average travel time? How long will they have to wait before they get on the tram and be able to make their ride? So that's, I think there are applications for that. It hasn't been used a lot because, for mass transit, obviously for longer distances like that light rail usually serves, it's going to provide much better capacity than a tram. So in an urban application, it's probably these shorter, distances that are more applicable. Actually, if you go to a lot of ski areas where they have these high peak times of travel between, say, the village and the base of the ski area, they'll use a gondola system because it's much better, it's much more efficient in getting people up and down the hill. Even with the smaller cars, you got these car after car after car, it'll have a much higher capacity than a tram system. So, in applications like that, maybe that the gondola is a better application than the tram if the ridership warrants that. Yes.
One last quick question, then we should probably wrap up. But the question I have is for let's call them the stations, the Barber and the North Macadam stations. As Jerry was indicating, there's going to be a sort of spatial need for lots of buses to be able to be stored and parked and available, and for the mode switch. So do you envision what I would call transit centers, full-fledged transit centers, maybe even with some short-term or long-term parking, other sorts of amenities for changing modes at those two locations?
North Macadam is a little bit better developed at this point than the Barber stop. North Macadam, there's always been this idea of what we call the transit hub down there, the interface between both bus and surface transit along the surface streets there, streetcar coming down to the district, and the tram. So you have these three modes coming together at one location. Probably not, in terms of design and everything, not too dissimilar than the urban plaza itself, in the sense of trying to provide a quality urban interface between those. North Macadam is very constrained, though, from a transportation perspective. And one of the questions that is constantly coming up about the tram is, are you going to build park and ride down here at the bottom of this thing? Is this going to be where people park and then ride up to North Macadam or up to Marquam Hill? And the answer is no. This is not a park and ride facility. North Macadam has enough transportation constraints without adding in all of Marquam Hills. So the transportation capacity down there needs to be reserved for development in North Macadam. So this is really an interconnector, not a park and ride type facility. Barber needs more thought, more help. There'd be a lot of value, I think, to thinking about those things for Barber, even from a vehicular standpoint, to say how can you take these vehicles off of Marquam Hill, maybe serve them in some other way. So.
Great. Well, let's thank Matt for coming today.
Thank you. Thank you.
Let me just say a word about next week. Next week, Scott Bricker from the Bicycle Transportation Alliance will be here talking about youth mobility concepts. So we'll look forward to seeing you next week. And I think Jennifer is going to talk about the syllabus for the students who are taking this for credit.
Yeah.